Notice how I have summarized the results here, leaving room for us to complete an example. So, as an example, let us say theta is equal to 20 degrees. All right, so sine theta equals. In a future video, we will discuss how to obtain exact values for sine and cosine, but those only occur at certain angles. 20 degrees is not one of them. So on my calculator, I have found that sine of 20 degrees is approximately equal to 0.342 ... Using this information, let us find cosine of 20 degrees. How are we going to do that, you might ask? We can use our Pythagorean identity. Cosine of 20 degrees is going to be the square root of 1 minus sine squared of 20 degrees. I can simply plug in my answer, 1 minus 0.342 squared. That's going to be about equal to 0.9397. All right. I should have specified here to keep 4 decimal places. All right, so that's cosine of 20. Let us find tangent of 20 degrees. How are we going to find the tangent of 20 degrees? Well, let's look at one of these formulas here to see if that will help us out. You see any here? Well, maybe not immediately. Let's think of it this way. If I draw a reference triangle, and I note this here is 20 degrees, I've said that sine is 0.3420. That assumes a hypotenuse of length 1. Cosine we calculated effectively by using the Pythagorean theorem is 0.9397. Sine is opposite over hypotenuse. Cosine is adjacent over hypotenuse. Tangent is opposite over adjacent. So tangent 20 degrees is sine 20 degrees over cosine 20 degrees, which is equal to 0.3420 divided by 0.9397. Okay, if I plug that into my calculator, I obtain 0.3639. Moral of the story there is that when in doubt, use a reference triangle to help you visualize your relationships between sine, cosine, and tangent. What if I want to find sine of 40 degrees? How am I going to find sine of 40 degrees? Well, notice that's twice 20 degrees. So I can use my double angle formula. So this is going to equal 2 times the sine of 20 degrees times the cosine of 20 degrees, which is equal to 2 times 0.3420 times 0.9397. By plugging it into my calculator, I get 0.6428. Very good. Now how about cosine? Cosine of 40 degrees is equal to, well, how am I going to find that? I'll come down to my double angle identity for cosine and find cosine of 2 theta is equal to this. So that's going to be cosine squared of 20 degrees minus sine squared of 20 degrees. So that's going to be 0.9397 squared minus 0.3420 squared. Okay, plug that into my calculator. I get 0.7661. Okay, do you see another way I could have obtained this answer using one of these identities? I'll let you take a look and see if you can figure out an alternative way. Now, what about checking our answer? Okay, let's go back and draw another reference triangle. This time, theta is equal to 40 degrees. Sine is 0.6428, and cosine is 0.7661. Now, I should check that this is x and this is y. X squared plus y squared better equal 1 on my hypotenuse. So let me try that.
0.7661 squared plus 0.6428 squared is equal to?
Well, I'm getting 1.0001. So within rounding, I would say we are quite close. In answer to my previous question, once we obtained sine of 40 degrees, we could have used the Pythagorean identity to calculate cosine of 40 degrees. But notice that's how I checked my answers. Now for tangent of 40 degrees. Well, how are we going to do that? How about the double angle identity for tangent? So that's going to be 2 times tangent of 20 degrees over 1 minus tangent squared of 20 degrees. Okay, so we have that number from here. 2 times 0.3639 divided by 1 minus 0.3639 squared. Okay, I'm getting 0.8389 to 4 decimal places. Again, how do I check this answer? Well, I'll come back to my triangle. Y over x, sine over cosine.
0.6428 divided by 0.7661.
And I get 0.8390. So within rounding, we are accurate. My chalkboard is becoming too small. Sine of 10 degrees. This is going to require use of the half angle identities. So this is going to equal 1 plus cosine of, well, 2 times 10 is 20 degrees divided by 2. Notice this is sine squared. So that negative sign got me again. And we have to take the square root of the whole thing. So 1 minus, well, cosine of 20 is 0.9397. Divide that by 2 and take the square root. And what do I get? 0.1736. Okay? How about cosine of 10 degrees? Well, that's going to look very similar, also using the half angle identity. This is going to be 1 plus cosine of 20 degrees divided by 2. And again, take the square root at the end. 1 plus 0.9397 divided by 2 square root. 0.98 8, 4, 8. I'll draw my reference triangle down here, this time with theta equal to 10 degrees. Sine is 0.1736. Cosine is 0.9848. Let's try tangent using the half angle identity I just erased. Tangent of 10 degrees is equal to 1 minus cosine of 20 degrees over 1 plus cosine of 20 degrees. And the square root of all that. 1 minus 0.9397 divided by 1 plus 0.9397. Square root. And I get 0.1763. Incidentally, that's very close to sine with the last two digits flipped. So I'll check my answer. This divided by that should give me that.
Sine is 0.1736 over cosine 0.9848. I get 0.1763.
So, looks like it checks out according to our reference triangle. Hopefully you were able to follow along my example. Make sure when using your calculator you're careful of orders of operation. For your homework, I want you, given theta equal to 32 degrees, and I'll give you sine of 32 degrees is equal to 0.5299. This is another angle that cannot be represented exactly, so we'll use decimal representation up to 4 decimal digits. I want you to find cosine theta, tangent theta, and of course sine theta for theta equals 16 degrees and theta equals 64 degrees. So your homework is going to look very similar to the example we just did. You'll be finding sine, cosine, tangent for 3 different angles, 16, 32, and 64, using the identities. So go ahead, follow through with that. Comment below what you got, and let's have a discussion about this. As always, thank you for watching, and I will see you again next time.